A few years ago, my computer changed its clock to the wrong date and time several times. It was very disorienting. First I went on tea break like the Hatter, but then I decided to fix time for good. The international time signal synchronizes everything, but what is this construct we call time? Where is it coming from, and how do we know it's right? When I measured the sun, it was highest at 1:20, not noon. Local time was centered on daylight for centuries, but Earth is tilted. Days slow down, speed up, and drift earlier and later. Modern clocks run at a constant rate and are fixed within time zones. Mean time is calculated from observations of Earth's position, regulated by atomic clocks, and distributed by the Universal Coordinated Time Signal, which also has the date. To verify the time, a scale was needed against which to check the sun position. But UTC is out of step with reality and also took the 12-hour clock face. To indicate local time, I needed a different format. Several clock faces were designed in Excel, which calculated local time. The program worked as a clock. Checking the sun position proved it was right. Calculations were roughly the reverse of navigation using the sun, but without waiting for noon. My experimental sundials were similar to an Egyptian shadow clock, but were difficult to position and use. The program was improved to show angles and numbers for the sundial, and the manual inputs like location and sunrise were automated so it could show the right local time when turned on. Moon position was also developed in Excel to check the time at night. The final sundial is easy to make and use. It has a 360-degree scale with central screw to cast shadows. Two arms assist with readings. When the phone is held sideways, the DarkSide clock can display sun and moon angles, but the sundial is needed for 1 degree accuracy. Point the box north using the current sun direction and mark its position. This must be done quickly because Earth rotates 1 degree every 4 minutes. Moon angles are obtained by direct sighting, and elevation is measured with a sextant day or night. Measure to the middle of the moon, which may be dark. To share the program, it needed converting to Java for Androids. DarkSide is available as a free app from Google Play. When first installed, it takes a few minutes to get a GPS fix and show the right local time. DarkSide displays a clock face representing the percentage of the day or night remaining, rather like a fuel meter. It divides the local day into almost equal periods, which are always growing or shrinking. Here we show the current day and night for San Francisco, London, and New York. Countdown alarms may be set in UTC or local time. Most of the screen features are selectable, and brightness can be changed for night viewing. The initial sun check had a 200-to-1 probability of being right, since an error results in the sun being somewhere else. But this could not prove the date was right. The moon crosses the sky slower than the sun, losing 14 degrees each day, so it can verify the date. If both the sun and moon are correct, the probability of having the right time is as unique as an eclipse. Making use of the moon is cool, but the question remained, how do you find the time if it's wrong? DarkSide now needs 6 numbers to find time. GPS and 2 angles each for the sun and moon. Long pressing the DarkSide mode button gives the current 6 values, which can be changed if they're wrong. The sun and moon may be entered at different times. When all values are saved, the program searches for time. This tablet has the wrong time set. We give it the numbers for current date and time as reported by the phone. As you'd expect, they get the same answer. The calculated time signal is a 10-digit number called epoch seconds, but DarkSide also shows the familiar Gregorian calendar, date, and time in 24-hour format. Here's how you do it. Step 1 is to mark our meridian line, then open the search screen and reset the angles using the Save button, long press. Use the sundial to capture sun angles, enter and save them. Use the sundial to get moon shadow direction, then use the sextant for elevation. Pull the moon down below the horizon to compensate for parallax. The program will run past today's date if the angles have more than 1 degree error. Pressing continue checks for 2-degree results.